When you hear the word tuberculosis, you might think of something from a history book, right? Well, the thing is, it's still one of the deadliest infectious killers on the planet. Today, we're going to go deep right inside the human body to see this incredible microscopic war between our own immune system and this really clever bacterium. It's a fight that's been going on for ages and is still shaping our world.
Okay, let's just start with one number to really set the scene. 10.6 million. That's the estimated number of people who got sick with TB in 2022 alone. This isn't some old statistic. This is happening right now as we speak.
So how do you even wrap your head around a number that big? Well, here's how we're going to tackle it. We're going to do this kind of zoom in, zoom out thing. We'll start big with the global picture, then we'll dive way down to the microscopic level, right into the battle happening inside our bodies. Sound good? Okay, let's dive in. All right, first, let's zoom all the way out. Let's look at TB's massive and really unequal footprint across the globe. You'll see pretty quickly that this isn't just a story about a germ, it's a story about where you live. And look at this. It's immediately obvious that TB is not an equal opportunity disease. Not at all. Almost half of all cases are in Southeast Asia, another quarter in Africa. And this isn't random. This pattern lines up almost perfectly with things like poverty and access to healthcare. And if that wasn't bad enough, the problem is getting more complicated. The bacteria themselves are evolving. They're becoming resistant to our drugs, which makes treating this so much harder. We're talking about an estimated 410,000 cases of multi-drug-resistant TB in 2022. That's a whole other level of threat. Okay, so we've seen the big picture. Now let's zoom in a bit to the personal level. How does a disease this widespread actually travel from one person to the next? Right. The key thing to get here is that TB is an airborne pathogen, but that doesn't mean it's super easy to catch. It's not like you can get it from shaking hands or sharing food. No, it's all about breathing in the same air as someone who has the active disease and is coughing, sneezing, or even singing. And this brings us to what is maybe the most important thing you need to understand about tuberculosis. It's the key to how it affects millions, and it all comes down to a really critical difference, the difference between being infected and actually being sick. So here's a question for you. Is it possible to have the TB bacteria in your body and have absolutely no idea? The answer is a huge yes, and this chart shows it perfectly. There's latent TB and there's active TB disease. With a latent infection, the bacteria are in your body, but they're sleeping, you could say. Your immune system has them walled off. You don't feel sick, and you can't spread it to anyone. But if your immune system gets weaker, those bacteria can wake up and start attacking. That's when you have active TB disease. Now you feel sick, and now you are contagious. So that just raises a huge question, right? How does this bacterium manage to hide out in our bodies, sometimes for decades? To answer that, we have to zoom way, way down to the microscopic level. This is where it gets really clever. The bacterium, Mycobacterium tuberculosis, has this wild strategy. It basically lets itself get eaten by one of our own immune cells, a macrophage. But instead of being destroyed, it uses this like a cloaking device called cord factor to block that from happening. So it turns our own immune defender into its own personal hiding spot, a Trojan horse where it can multiply in secret. But our body is smart too. It fights back. It sends in other immune cells to surround the infected one, building this kind of wall around it. This structure is called a granuloma, and it's basically a biological prison that keeps the bacteria contained. This is the stalemate we were talking about. This is latent TB. So what happens when that stalemate breaks? What happens when the battle is lost and the infection turns into active disease? Well, it can happen in a couple of ways. Sometimes, right after you're first exposed, your body just can't contain it. That's called primary TB. But what's way more common is secondary TB. This is when a latent infection that you've had for years, maybe even decades, reactivates. This usually happens when your immune system gets weaker for some other reason and the bacteria see their chance to break out. And when the disease does become active, man, the symptoms are rough. You've got the classic signs like fever, weight loss, and those terrible night sweats. But in the lungs, where the main battle is happening, it causes this persistent, productive cough that just won't go away, and you feel this increasing shortness of breath as the bacteria literally destroy your lung tissue. Okay, so finally, let's zoom out one last time.
It turns out the bacterium that causes TB has a lot of relatives, a whole family of atypical mycobacteria that are important to know about too.
Yeah, so there's this whole group of over 100 related bacteria that you can find pretty much everywhere, in soil, in water. Like the TB bacterium, they're acid fast, but they don't cause tuberculosis or leprosy. They're kind of their own thing.
And for the most part, these guys are opportunists. They don't usually cause problems for people with strong immune systems. But for someone whose immune system is weakened, like a patient with AIDS, something like MVM intracellulare can cause a really serious lung disease. There are others too, like M. marinum, which can cause skin infections people sometimes call swimming pool granuloma.
And that really brings us to a crucial point about the connection between TB and AIDS. It's a truly deadly partnership. Each one of these diseases makes the other one worse. Think about it. HIV weakens the immune system, which lets latent TB break out. Then the active TB infection actually helps the HIV virus spread faster in the body. They just feed off each other in the worst possible way. So we end on this thought. As this ancient killer keeps evolving, getting resistant to our best drugs, are we really prepared for what's next? TB is not some relic of the past. It's an evolving threat that continues to challenge us. And understanding its strategies, how it hides, how it fights back, that's the first step in winning this ongoing battle.